Welcome to lesson number 1. This is on multiplying radicals. And so the previous lesson we were looking at adding and subtracting radicals, but now we're on to multiplying radicals. So if we have two radicals and you see a multiplication sign, what do you do? Alright, so in this investigation, all we want to do is determine whether each of these are true or false. And so whether or not when I plug this into my calculator, am I going to get a true statement or a false statement? So let's look at this first one. We're going to go with the square root of 2 times the square root of 3. And I get 2.449489743. And if I were to plug in the square root of 6, is this going to equal this? And the answer is yes. So this means this is a true statement. Let's move on to B. If I have 2 times square root of 5 times negative 4 times the square root of 3, will that equal negative 8 square root 15? Well, let's plug negative 8 square root 15 in, and yes, that is also true. So this times this does equal this. Now let's try square root of 2 times the cube root of 4. Does that equal the cube root of 8? Well, square root of 2 times the the cube root of 4 is equal to 2.244. And let's see what the cube root of 8 is equal to. So math button, option 4 and 8. Well, we know that's going to be equal to 2. And so these are not equal. Alright, so you can do the same thing for these two and determine whether or not they're true or false. And yeah, let me know what you get for these ones. Alright, and for this lesson, I'm going to check to make sure you did these two. Alright, so I'm going to highlight these in pink, and these are something I'm going to check. So based on the results from A, and we're going to say C, write a rule which describes the process of multiplying radicals. So when we were multiplying radicals, these two ended up being true and this one was false. So what I did here was, since these two are equal, I could say that 2 times 3 is equal to 6, and in which case I'm multiplying my radicand by my radicand. So multiply radicand by radicand. And so if you're confused about what a radicand is, I'm going to highlight it in blue right here. This is my radicand. That's the number in the radical sign. Next, we also said that this was a true statement, and I did multiply my radicand by my radicand here as well. It's 5 times 3 is 15, but I also multiplied my coefficient by my coefficient. And so that's another rule, is multiply coefficient, which I highlighted in green, by coefficient. Alright, so my radicand I highlighted in blue, and my coefficient I highlighted in green. And the last thing that we had to do for a true statement, notice how this was not true, we multiply our index. Well, we don't multiply our indexes, but the indexes have to be the same. Have to be the same value. So if we look at what our indexes were in each of these cases, in both these cases we had an index of 2, right? It didn't show it there, and it doesn't show it there, meaning it is an index of 2. Now with number C, letter C, we had indexes of 3 and an index of 2, which means that we couldn't multiply those ones together. So moving on to example number 1, and all these rules we just highlighted here are found in this option as well. So if we look at class example 1, they want us to multiply and simplify wherever possible. So let's look at A. Well, it is possible to multiply here. We can go 8 times 8, which would be the square root of 64. And if we were to simplify, square root of 64 we know is 8. And so here is an example where I went my radicand multiplied by my radicand. And so again, highlight that in blue, but radicand times radicand gives you a new radicand. And this square root of 64 is equal to 8. Now if we look, we have the same index, and in the previous one we also had the same index of 2, and we also have an index of 2, and that's where we really need to begin looking. But what we have to do, remember, is multiply our coefficients now by our coefficients. So 4 times 3 is equal to 12. And next we need to multiply our radicand by our radicand. So 5 times 6, and I'm going to get square root of 30. So I multiplied my coefficients to get 12, and I multiplied my radicand to get 30. Next I have option C here, or number C, but I have my coefficients and I have my radicands, and I have the same indexes, so I can multiply. That becomes 12. 4 times 3 is 12. Square root of x times y is just going to be xy. And so even if we don't have actual values, we're just given variables, we can still multiply those variables and get something like this: 12 times the square root of xy. Next, I have negative 2 times 5. That's going to give me negative 10. And square root of 8 times 12. 8 times 12 is 96. And we can simplify even further if we want, because I know that this one can be simplified. And if we look at a perfect square, that's going to go into 96. My lowest perfect square that goes in there, let's see if we can get 36, or not 3, 96 divided by, well, 36. That doesn't go in, so let's go lower. We know 25 won't go in, so how about 20 or 16? 6 times. So that's going to give me negative 10 times the square root of 16 times the square root of 6. That's going to leave me with 10 times 4 times the square root of 6, or negative 40 times the square root of 6. And so that's how we simplify and multiply radicals. So let's look at a couple more examples here. Our next example we have, class example number 2, we want to expand and simplify this expression. So square root of 5 times 2 times the square root of 10 minus square root of 5. And so first of all, if I'm going to simplify this, I need to distribute the square root 5 into my brackets. Alright, so I'm going to multiply these as well as this one here. And so this is if there's no coefficient, that means it has a coefficient of 1. And so 1 times 2 would just be 2, but square root of 5 times square root of 10 is going to give me square root of 50 minus the square root of 25. 5 times 5 is 25. This can be simplified, right? We know that 50 is made up of 25 times 2, so I'm going to say that's going to be 2 times square root of 25 times the square root of 2 minus square root of 25 is 5. So simplify this expression here, 2 times square root of 25. Well, 25, square root of 25 is 5, and I got my square root of 2 minus 5. And so if my final expression simplified, 2 times 5 is 10, square root 2 minus 5. And then I do the same thing for this expression here. So 2 times the square root of 5, multiply this term. 2 times 3 is 6. 5 times 45 is going to be 225. So 5 times 45, 225. So square root of 225 minus 2 times this expression. So 2 times 8 is 16. 5 times 5 is 25, square root of 25. And my last expression, once I've distributed it finally, 2 times 3 is 6. 5 times 20 is 100. We're not done yet because we need to simplify. So 225 is a perfect square, right? 15. And if you're unsure, just double check. So 15. So that becomes 6 times 15 minus 16. 25 is a perfect square. That becomes 5. And 100 is also a perfect square, and that becomes 10. So 6 times 15 is 90 minus 16 times 5 is 80 plus 6 times 10 is 60. So we simplify that. 90 minus 80 is 10 plus 60 gives us 70. Alright, so we're going to do the exact same thing in this problem here. And this one, I'm going to do this one just because we've got some variables in here, and I know that as soon as some of you see these variables, you are going to be a little bit concerned. So let's take a look at this one. So the same rules are going to apply. I know that this first value has a coefficient of -4, and there's no coefficient shown here, which means that it is 1. So -4 times 1 is just -4. But a times a is going to give me a squared. And a negative is going to be a positive. 4 times 9 is 36. A times b is going to give me square root of ab. If I look at this 4, or sorry, not the 4, but this a squared, that's a perfect square. And so this can come out of the brackets, and that's just going to be -4a plus 36 times times the square root of AB. Next I have these two problems here. I want to write and simplify an expression for the area of each shape. And so for both of these, the area is going to equal the length times width. This one as well, area equals length times width, or side squared, so side squared and length times width for my areas. And so here's my width, here's my length, and so my area is equal to 7 minus square root of 6 times 4 plus the square root of 6. Here we're going to need to use our distributive method, and so 7 times 4 is 28. 7 times square root of 6 is going to be 7 root 6. -6 times, or negative square root 6 times 4 is going to give me -4 square root 6. And square root 6 and square root 6 is going to give me negative square root of 36. I can simplify this expression. That gives me 28 plus 7 root 6 doesn't simplify any further, and -4 root 6, I should have expanded this, so this is why you should do things in pencil, but 7 minus 4 is going to give me 3 root 6, and negative square root of 36 is just -6. And so my final answer is going to be, if I combine my like terms, so highlight my like terms, 28 and -6 is going to give me 22 plus 3 root 6. And you're going to do the exact same thing for this one, but now because you have a square, you know that this is also 2 root 18 minus root 27. So this is another one I want to check to make sure you've attempted. So here would be a good place to pause the video and to try this one. Alright, next, multiplying conjugate binomials. And so all a conjugate binomial is a pair of binomials, so made up of two numbers, that have opposite signs. And so notice how in this example, square root of 5 minus square root of 2, notice that minus sign, and then similarly square root of 5 plus the square root of 2 right there. So, well, how could we tackle this? Well, I know that square root of 5 times the square root of 5 is going to be square root of 25, which just equals 5. I know that my next term is going to be 5 times 2 is square root 10, and negative 2 times square root of 5 is going to be negative square root 10. And if I have square root 2 times square root 2, that's square root 4, or just 2. And so all we do is when we simplify this, this ends up being, well, these two terms are going to cancel out. This is positive and this is negative, and they're equal. And now I have these two like terms. 5 minus 2 is equal to 3. And then if I do the same thing over here, I'm left with, well, 2 and 7. 2 times 2 is 4. Here, I'm just going to do this the long way. So 2 times 2 is 4. Root 7 is root 49. Minus 16 root 7 plus 16 root 7 minus 64. Root 49 is 7, so that becomes 4 times 7, which is 28. These cancel out, and I'm left with negative 64. Simplify this, I left with negative 36. So whenever you have your multiplying conjugate binomials, what do you notice about the product of the two conjugate binomials? Well, there is no radical sign, right? In either case, there's no radical sign that we have to worry about for our final answer. Last example, we want to find the conjugate of each and then multiply each pair. And so remember, all a conjugate is when we have, if this is my binomial, then the conjugate would be 4 root 6 instead of positive 3 minus 3. This one here, if I'm looking for my conjugate, instead of negative 3 root 11 plus square root of 2, it's going to be minus the square root of 2. And for C, it's going to be 5 square root of x instead of minus square root of y, it's going to be plus the square root of y. And I'll do the one that looks like the most complicated, I guess. So let's go with this one here, and I'm going to rewrite it. So if I multiply my conjugates, I have negative 3 root 11 plus root 2 times negative 3 root 11 minus the square root of 2. So negative 3 and negative 3, I'm going to be left with positive 9, and square root of 11 times the square root of 11 is just going to leave me with 11. I know that it's going to give me 121 square root, which gives me 11. So I've multiplied those two. I know that if I multiply this and then multiply this, those middle terms are just going to cancel out. But let's do it anyways. So negative times a negative is going to give me positive 3 square root 22. Positive times a negative here is going to give me negative 3 square root 22. And square root of 2 times square root of 2 is just going to give me 2. So that's also going to be negative. These cancel out. 9 times 11 is 99 minus 2 is equal to 97. These two examples, make sure you give them a try. You can pause it here, test them out, and yeah, let me know what you get.